Welcome to February 5th LeetCode Challenge. Merge K sorted lists. You're given an array of K linked lists called list. Each linked list is sorted in ascending order. Merge all the linked lists into one sorted linked list and return it. So we're given a list of lists here, which is the array, given the K linked list array. Each of these inside are linked lists, and they're sorted. And what we want to do is link them all together, sorted again. So the linked lists are as such. One's linked to 4, which is linked to 5, and the next array is 1's linked to 3, linked to 4, and then the third array is 2 is linked to 6. Merging them all together, you have 1 points to 2, 1 points to 2, points to 3, points to 4, points to 4, points to 5, points to 6. So it's basically combining all these linked lists together such that it is 1 in sorted order, all the arrays together, and it's in ascending order as well. So that's pretty much it. Example number 2, if it's empty, return empty. If the array of an array is empty, then return empty as well. So our constraints are as such. Listed I is sorted in ascending order. And yep, that's pretty much it. So for this approach, I mean, you can use heap sort, or you can use some other type of algorithm as well. I'm just probably gonna do a brute force approach, where let's think of this. So say we traverse through all the linked lists and collect the values of the node into an array. Right? We just travel all the linked lists and we just collect all the values into an array. So we basically convert each of these linked lists into we get the value of it and turn it into an array. And then with the array, we put everything, all the numbers inside. We just sort that, right, and iterate through the array and of the proper values for the node. And then we would just reconstruct the linked list. So create a new sorted linked list and then extend it with the new nodes. That's pretty much it. So that's like a brute force approach. So yeah, that's pretty much what I'm going to do. Just basically deconstruct it into all the values and put it into an array, sort the array, then put it back into a linked list. Not the most elegant approach, but it's the one that kind of, it'll work. So the first thing you're going to do is define a node that we're going to add to. So it's going to be, the next thing I'm going to do is create a head pointer. So we have define head, of course. Define a pointer, a point for it, and then define a linked list of size of starting at 0. So I'm just using the linked node, list node class to create a new list here called head and point. And then we're just going to iterate through. Now that we have those two initialized, we're ready to basically iterate through our list. So for L in list, while L exists, what we want to do is self.node.append the linked list value into the array of so this is the array we initialized called nodes. We have to use a self function there. What we want to do is for each list element, what the list exists. So if we have a list within the list, then we append the list value to our array called nodes. And then once we have that, we go to the next list item or list value, list.next. That's pretty much it for there, and then we append it. Next thing we want to do is create a new linked list by sorting it. So for x and sorted, using a sorted just algorithm of sorted.self.nodes. So for each element in our sorted array, we're going to call it points. So points is our linked. So what we're going to do is We have head already. Now what we're going to do is add each point or each value onto head. So what we're going to do is point.next. We make a list node structure of x, which is the value that we're going to put it in. Basically, take the value, make it into a node, and call it point.next. And then we just put it onto our point, where we do point.next. So with that, basically, we make it to list node, then we just keep on iterating through and make all the nodes there, and then we just have to return the head.next. So basically what we want to do is append all the nodes together, and then we just return that one linked list. And this should work. Seems good. Okay, accepted. So time complexity is big O of n log n. The reason being is that n is the total number of nodes, but we also have our stable sorting algorithm here as well. So let's just we collect all. So this for loop right here, this iteration is basically collecting all the values. It costs big O of n times, right? And then we have a sorting algorithm as well. So we do a for loop, which is big O of n, and log n function of that as well. So iterating through creating the value of the linked list costs big O of n, and sorting it costs log n. Time complexity, that is time complexity. And space complexity is big O of n, because the sorting algorithm costs big O of n space, depending on whatever sorting algorithm you use. This one costs big O of n. And then creating the new linked list as well costs big O of n. But yeah, that's pretty much it. Have a good day, guys.